Hello everyone, this is Shruti Khandelwal and this is my first internship project of iNeuron on the topic wine quality analysis. This is my dataset information. The dataset I downloaded it from UCI repository, and the dataset I got are of wine samples, and that is red and white, and in which we have to model wine quality based on the physiochemical test, and the physiochemical test here are our inputs, and based on these inputs we have to find the quality of a wine. So this is the attribute information where are like 11 input variables. These are physicochemical tests like fixed acidity, chlorides, density, pH, etc. And our output variable is quality, which is scored between 0 and 10. 0 is the lowest score, which means that our quality of the wine is very bad, and 10 is the highest score, which means the quality of wine is excellent. So now I'm going to start my project. I've used Jupyter Notebook, in which I coded, and then I started imported libraries, pandas, numpy, pandas for data processing, and Seaborn and Matplotlib for data visualization. And here I started my data pre-processing. I've loaded the CSV file of my data, and this is what the 5 rows looks like. Okay, all these are attributes information, qualities are output variable, these all are our input variables on which we have to find the quality. As you can see, these are mentioned here like 720. On the basis of these inputs, our quality is 6. So we have to find the quality of the wine based on this information. Okay, now we are going to know that what are the total number of rows and columns of our data set. So basically it is 6497 and 13 columns. 6497 are rows and 13 are columns. And then let's get the complete information about our data set. So we can say that there are some null values we can see here, and all data type are, most of them are float, and one is object, that is type, and type includes white and red wine, and quality is an integer which is scored between 0 to 10, as I've already mentioned it. Okay, these df columns, these are column names and the data types. So I've renamed the columns so that I don't get any further issue while processing my model. So I'm going to check my duplicates here. So I've checked the duplicate and it was 1168. That is a very huge amount, and I've dropped the duplicates by using df.drop duplicates. Now my duplicates are removed. So now I'm going to again check my data set, the number of rows and columns. Here I can see that now my data set is, total number of rows are 5329 and 13 columns. So this is my complete data set here, which I'm going to use. So now I'm going to check the null values here. We can see that fixed acidity has 10 null values, 8, 3, 2, 2, 2, and sulfates are 4. So what we are going to do is, we are going to, as these numbers are very low, we are going to fill this number up. And how are we going to do that? We can fill it by using median and mean. And we use mean where our data set is of normal distribution, and we use median where our data set is not in normal distribution. So according to that, I have filled it missing values by mean and by median. Now you can see that all my columns are completely free from missing values. So this is the statistical information I can see here. As we can see here that residual sugar have outliers, free sulfur dioxide has outliers here, this column has also outliers here. Okay, so we are going to remove these outliers now. So what we can do first is to print it to know how many columns have actually the outliers. So we can see here that this is a residual sugar column, sulfur dioxide, and free total and free, both all of these three columns have outliers. So we're going to remove it. So basically the outlier this is the proper way to remove the outlier, and there is one other function to remove it. So I've used it, and now my outliers have been removed. So I've saved this data set into Excel. This is my clean file basically. Now we are done one part encoding here. Basically in this, what I have done is I've done the white and red bind into zero in binary form, that is 0 and 1. 1 represent white here and red represents 0 here. Now you can see here, this is wherever the type of wine is white, it is 1, and wherever is 0, that means that it is a red wine. Okay, now we can drop the type form, type column. So this is a sample of a data set. I have taken 10 samples. These are all random samples. I've mentioned it here. Now we are going to do EDA now, and the univariate analysis, where I've seen that the quality of the wine, the minimum quality, the minimum number of quality we get is 3, and maximum quality unit we get is 9. So our quality of the wine is in between 3 and 9. Okay, the most number of our quality unit is lie between 5 and 6. So we can guess here that most of the wines are of medium quality here. So what I've did here is I've used an logarithm function here, so that because there are so many outliers and residual sugar, so I did this thing. And now bivariate analysis between the two columns, so I can see here that relationship between fixed acidity and quality. Okay, so all of the between 6 to 8 fixed acidity, we can see here that all of them most lie between are of medium to high quality. We can see here that the volatile acidity, this represents that the bad quality wine has more volatile acidity, and the excellent quality wine has low volatile acidity. And alcohol and quality, the excellent wine has highest alcohol quantity, while the 3, 4, 5, these are of low and medium quality wines have low alcohol, and this represents the low quality of wine. So citric acid, the more the citric acid, I think the better the quality of the wine, as we can see here. Chlorides, the less number of chlorides, the better the quality of our wine. And almost same with sulfur dioxide. So now we're going to find the correlation between our features. So I've done this thing. I've mapped this thing for my target variable. So what I've did here is I used the map function to represent 3, 4, 5, 6, 7, 8, 9 to represent low, medium, high quality wines, and then I did use a map function again to mark the low as 0, medium as 1, and high as 2. So I don't get confused while model training. So now I'm going to for the processes of my model development, I imported some libraries from sklearn. I've imported the sklearn library basically here, and I've dropped the column x is our independent variable and y is our dependent variable. So we drop the quality and white because we don't need that thing, and here y we have to predict this thing. What I've did here is the y value, if it is greater than 1 or equal to 1, then our wine quality is good, and if it is less than 1 or 0, then our wine quality is bad. So on the basis of that, I've used the 3 algorithms here. First is logistic regression I use here, and I've got the 96 accuracy. Then decision tree, I got 93 accuracy, and then I used random forest classifier, which is 96% accuracy, which is slightly more than logistic regression. So I've picked the random forest classifier for my project, and then I got, and to, and then I imported the classification report here. As you can see, precision, call, F1 score, and support. Now I'm here going to predict my wine quality. So I told you, like, if my prediction number is 1, then my wine quality is good. If my prediction number is 0, then my wine quality is bad. So what I have did is I deployed this model on Streamlit. Then I installed Streamlit on my Jupyter notebook. I've used the pickle. I've saved the model basically, and the further process I did in Spider. So this is the same step I did here. Basically, you can download Spider from Anaconda and Anaconda, and this is where I use a Streamlit to develop my single web page, as you can see here. And this is then all the files I've uploaded to the GitHub, and here I attached my Streamlit to the GitHub directly where I've deployed the model. And this is my app link. Here it is. So this is my wine quality prediction web app. Here we can see that all the quantities are 0. So obviously it is going to be a bad wine because nothing is because our input is almost 0. So here we can see that the wine quality is bad. If we try to get some input here, then we can see that, as we have just read, the more the citric acid, the more good the wine, excellent the wine. Okay, density is almost 1, I've seen. pH, yes. And alcohol quality, the more the good. So our wine quality is good. If we take almost complete full values, then this is going to be the most baddest wine we can ever see. So this is my complete project. Thank you for viewing this. Thank you so much.